Hi, my name is Antony Jones. I am the CTO of Beyonc, which is a software as a service platform and marketplace for experienced leaders. Currently on furlough, giving me a bit more time to fulfill my second role as Svelte maintainer. I produced this talk, Authentication in Sapper. The reason being that it can be tricky. It's not necessarily difficult, but it can be trickier than a regular client-side only application because you've got a server-side and a client-side almost as two completely separate applications. A lot of people implement the authentication only in the client-side in the browser, and that can cause a few problems, as we'll see as we go through the presentation. So, authentication is something a lot of applications need. It's a common requirement. You authenticate the server, which is a source of truth, meaning that you are authenticating the full application and not just the client side. A lot of tutorials and blogs will show you how to authenticate a Sapper application. I've read through a few of them, and they're not necessarily wrong, but you really want to authenticate the whole application rather than just the client side. And very few of them touch upon this going towards using client-side applications, client-side SDKs only, and sort of forgetting about the server side. There's a few boilerplates and seeds out there that show you how this process works and fits together. I've even created one for this presentation I'm going to call the MVP. However, it's nice to know how this works underneath, and more importantly, why it works underneath. So, in a traditional client-side application, you have a browser-based JavaScript application, which is a single-page application, which has a cookie. That cookie is set by the API, and it sends that cookie back to the API, or the browser sends that cookie back to the API every time you make a request, therefore authenticating your requests. In Sapper, of course, you have a second part, which is the server-side part of that application. And the mistake if you use a client-side only based authentication solution is that the server side of that application will not be authenticated, and you'll get a flash of content, or a FOC. It's not a rude word, it's just the acronym FOC, FOC, flash of content, which will mean that your users see a page of unauthenticated content before they see the authenticated content which actually belongs to them. This can look pretty janky if you've got it in a full application online. So what you have to do, you move the cookie passing to the server side of the SSR part of the Sapper application. So what happens is the server receives the cookie, decodes it, and takes the cookie contents and puts them in the session store in Sapper. What this means is the client no longer have to need any knowledge of the cookie whatsoever. The browser will still have that cookie and can still send it to the API and receive it from the API, but it doesn't need to understand the contents, it doesn't need to be able to even see the cookie, and in fact if you set HTTP only, you won't even see that cookie in the client-side JavaScript, which prevents things like cookie stealing, hijacking, cloning, all those sort of security attacks that you might get if you weren't using an HTTP only cookie in your browser. The advantage to having it on the server side, of course, as well, is you can use this .fetch in Sapper's server-side part of the roots, and that will send your full credentials, including your JWT cookie, to the server each time, so the server can respond with authenticated responses to the server as well as the client. You can also, you can do that from either the client side or the server side. They almost become one. It's an isomorphic way of doing things. This .fetch is a server-side representation of the fetch object that's built into browsers. So, flash of content, what does it look like? It looks a bit like this. You've got a browser, you hit the page, you immediately see hello undefined because you don't have a session. The server-side rendering part renders the HTML for you and sends it to your browser before the client side even had a chance to load, and there's no authentication, you didn't know who you are. So only when the client-side application loads, which has the browser cookie, do you see your authenticated content. And this is a mistake a lot of applications make. So, the application architecture. The important thing about this architecture is that these two applications, there's an API side and a Sapper. So there's a happy API and there's a Sapper client. Two different applications. They should live on the same domain. The reason they should live on the same domain is because cookies are domain specific. If you set a cookie on a certain domain, It's only usable on that domain. So the application we're building, or we've built today rather, comprises of these two applications: the API, which has a post session, a delete session, and a get who am I, which is basically to get the profile information from the API. The post session creates a JWT and it puts that inside a cookie and sends that to your browser. The delete removes it, unstates it, it sets the expiry to be 1970 sometime, and deletes that cookie from your browser. So users can log out. So you've got login, log out, and then you've got get profile. What you'll see here, of course, is that the JWT is, because it's on the same domain, when you're making a request in the browser is requesting from the Sapper server, which means it's sending your cookies, because they are the same domain, it's sending those cookies to the server. And why that's important is because then when the server has the cookies, it can decode them, get the stuff it needs, and produce an authenticated server-side response. The client in this instance has no cookie visibility whatsoever. It lives in the browser, so it will get sent with every request to the API, but the JavaScript application on the client side cannot see this cookie. It is purely the SSR side, the server-side part of Sapper's responsibility to take the cookie, decode the contents, and then place them in the session store. Now, another important thing to understand here is that the Sapper application, even the server-side Sapper application, doesn't have any access, doesn't have any secret keys or seeds. What it has is it just reads the human readable part of the JWT, which we'll go into in a minute. It reads the human readable part of that, decodes that, and puts the contents of that into the client-side store and the server-side store as well, in fact. This is useful because I don't like to put any secrets inside my Sapper applications. I like to leave all of that stuff to the API, just in case they were to leak out at some point. So, why JWT? Why is JWT an important thing? It's for the reason I just discussed. The reason it's useful is because a JWT is actually two things. It's one, it's a very compressed, smaller version of your user's profile, but it's also in itself the auth token that gets passed to the API. So what this means is that you've got three parts to a JWT. You've got the payload in the middle, which is your user's profile. You've got the header, which tells you some metadata, meta information about the JWT, useful when you're decoding it, that sort of thing. And you've got the signature, which validates, it's like a checksum for the rest of the JWT. The signature validates that those two first parts of the JWT are valid. In the browser, you read the payload, you use information, it's just base64 basic information, it's just a bit of JSON maybe. It can be readable by anyone. If you try to tamper with that information, you may well be able to change your username in the application. It might show you a different username because, wow, you changed the JWT, but what it won't do is it won't work when you pass that to the API. The API uses the signature of the JWT to validate the whole thing is still valid and hasn't been modified or tampered with in any way before it reached the API. And the nice thing about the way the API works is that if the JWT isn't valid, what it can do is actually just delete the whole JWT, and then the user will be logged out. So, why do JWT Part 2? Why JWT is a useful thing? The reason being because the JWT is your session. It lives in the browser, it lives completely client-side. What that means is that your application has no fixation upon that session belonging to a certain server. In a traditional application, you end up with a session being a reference to a session in a database. It has to go to the same server, and the server has to fetch a record from the database, and you end up with a big tie there, so you can't scale your application. With a JWT, your session is passed every single time, it's verified every single time the request happens, and what that means is that you can have as many backends and as many frontends as you like, and any of those backends can send that JWT to any of those frontends, and it's absolutely fine. The session belongs in the client. So, the backend. The backend is a happy application. It uses happy because I prefer happy to express. I don't really believe in the middleware model. I'm a big believer in happy. It's a very strong, robust framework. It's very well tested. It's very well written, and it's performed well in everything I've thrown at it. And it's also very fast. There's a plugin called the Happy Auth JWT plugin, which I use because it's free and open source. Happy also has a commercial JWT plugin for an enterprise project. I don't use that, so I can't speak for how good it is, but it's probably pretty good. But this Happy Auth JWT2 plugin I've been using for years, and it's fantastic. It works really well, and it's really easy to use. It's really straightforward. The documentation is fantastic, so it's a really good plugin to use. The default authentication strategy of the backend application is JWT. So what that means is that every request, it will try to determine whether a JWT is being passed every time or not. Again, it has the 3 routes we've discussed before in the server. It has the create session, delete session, and retrieve user information. Each of these will use that JWT to determine what the operation is. If it's delete, it will remove the JWT. If it's create, it will create a brand new JWT. And if it's retrieve user information, it will take that JWT, it will verify it with a signature, check that it's valid, and then it will return the information from the database or wherever you're getting information from back to the user and saying, there's your information. So again, invalid cookies, invalid JWTs can be deleted, and that's brilliant because you have to worry about security anymore. So the front end, of course, it's a Sapper application. A Sapper application of 2 parts, a server side and a client side. The MVP I've built, and probably your application too, should use the browser's built-in fetch method. The reason the built-in fetch method is useful is because every modern browser has it. You don't need any libraries. If you look at Axios, which does a very similar thing, it's quite big, it's quite bulky, it's going to add a lot to your bundle size. Built-in fetch does everything you could ever need. It's a little bit more clunky to use because it's very bare bones. It's not a nice, clean API like Axios. It's more kind of functional, but it does work. There are solutions to get around the clunkiness we'll discuss a bit later on as well. Sapper also has, for preload methods, the isomorphic this.fetch method. This.fetch is essentially the same as browser-based fetch for the SSR, the server-side part of a Sapper application. It has the same API, so you don't need that cognitive overload of using a server-side fetch mechanism and a browser-side fetch mechanism. It's the same sort of thing, but the nice thing about it is it contains your authentication, your cookies, and your session. So when you make a request from the server side, you've got those browser cookies magically in that request that are being sent to the API. What happens in the front end is it requests a login session from the API and it receives a cookie that contains a JWT. It then stores that cookie in your browser, and the browser does all the rest of the work for you. As long as you stay on the same domain, that authentication is being sent every request to your API, every request to your application. When you're requesting a new page from the client-side application, of course, if you hit the server, that gets passed down to the server because it's all in the same domain. The server side becomes a source of truth for your authentication, which is really important because we want to make sure that the server's doing all the authentication work and the client's just being dumb and saying, hey, look, I'm just going to read out what you say exists and that's how it is. Nothing secure can happen in the client. All secure stuff goes to the API, and the API is validating the token. So there's no chance of someone tampering with this token in their browser and it being used for a malicious request in your API, because it's not going to pass validation. The checksum is going to be wrong. The signature is not going to match. Yeah, HTTP only. The client side cannot see the cookie, which is again another security mechanism. If JavaScript can't see it, that's brilliant because it means there's one less thing to worry about. User cloning the cookie, stealing the cookie, some malicious cross-site scripting injection, whatever, stealing that cookie and making a copy of it and looking at the contents, essentially stealing the user's email address perhaps. And then the client side gets all its information from the session store. Because that cookie is not visible, it's looking in the session store for all its information, and that session store, as we'll see in a minute, is available throughout your application. So the session store. The session store is populated by the middleware. The server.js file in Sapper takes the JWT, it decodes the human readable content, and it places that in the session store. That session store is then available to the whole server side. It's also available to the client side as well. There's 2 different ways of accessing that information based on whether you're server side or client side, but they basically revolve around that same session store. The session store is also a regular Svelte store. Sapper gives it to you, but it's a regular Svelte store, so it's completely reactive. If you update information in that store and you use it somewhere else in the application, or you're subscribed to that store somewhere, or you've got it printed in a page or whatever, if you change that information in the client side, then everything else is going to see that updated information. That store is reactive. It's going to see it instantly. It's just going to be bang, done. So on the server side, when you're in a preload method, you've got a page parameter and a session parameter. The session parameter, which is the second parameter of that preload method, is that session store. So in your preload, you have access to your full user session. You can pull out information, you can render it to the page, you can do whatever you want. That server-side rendered part of your route is going to have access to that session information. On the client side, again, slightly different syntax, but the Sapper/app package, so it's in the Sapper namespace, but it's the app package. That package has a stores property, which is a function. You can deconstruct whatever, when you call that function, the response can be deconstructed, and you can pull the session store out, as I've done here. That session store, again, it's the same reactive store. You can use it as you would any other store in your application. You can print it as an H1, as I've done there. Just simply read the value of it and write it to your page. You can do all sorts of crazy stuff. It's also worth noting that the store is a writable store. You can update it. So if you make a change again, everything else sees it. Brilliant, job done. So, improvements to the application. Improvements to the MVP that I've built. The MVP has been built to be very, very bare bones, a very basic example, and you'll see it's very, very basic. It's just an example of how authentication will work with very little outside, very few outside libraries. However, what I've done is I've written a couple of libraries as part of my work at Beyonc. The reason I've written these is because, like I said before, the HTTP client that's given to you by Fetch is very bare bones. You have to do multiple stages to read the JSON response. You've got to call, what is it now, .json, deconstruct the JSON for you and parse it. And if there's an error cause, you've got to catch that error. It gets repetitive after a while. You can't specify a base URL, you can't specify default headers, you can't specify, a default set of options for every request, so you're specifying that every time you use it. All the Beyonc Sapper HTTP client library does is it wraps that all up for you in a much more friendly sort of API. You pass in the fetch method or the this.fetch method depending on whether you're in the browser or in the client, and everything else is wrapped up. One particularly useful feature is that it can handle errors much more gracefully. So, for instance, a 404 or HTTP status 404 not found, or a 500 internal server error, or a 400, which is a bad request payload. It can handle all of these things with its API, simple methods, not found, takes in a method, and that method can handle that error for you. So you can handle errors in a much more readable way. The second library is the Sapper RBAC library. Now, RBAC stands for Role-Based Authentication Control. What this means, what this library does, is it allows you to specify a whitelist of operations, a whitelist of routes in order to protect them from certain user types. So, for instance, if you've got some specific admin routes, you can just simply define the regex admin / whatever, and say this route is only accessible by anybody with the admin role. It does this in quite a nice way. It does it on the client side and the server side. So no one's going to hack your app, no one's going to sort of play around and find a way to see pages they shouldn't be able to see. Now, don't forget your session, your cookie and authentication means that they won't see the content anyway, but they'll still see the page and it'll look pretty bad. So what the RBAC plugin does is it allows you to protect a whitelist of routes and say certain users can access certain routes. Dead simple. That's actually quite hard to do in Sapper as it currently stands. Maybe it'll improve in the future. But that plugin's really been a really useful thing for me. So there's two alternatives. If you don't want to roll your own authentication, which is a completely valid scenario, so managing your own user set, your own user database, managing your own password reset journeys, managing your whole login flow, third parties, SSO, social login, it can be a bit of a chore and it can take a lot of time. Sapper will allow you to integrate with these two, well, with many other potential options, but especially these two options here. So Auth0 calls itself an identity provider. What that means is it handles your whole user authentication lifecycle, and it can hook back into your Sapper application via a series of callbacks. Now, they do have libraries and SDKs, but they're very focused around being a client-side library or a node-based server-side library. There's nothing that takes into account the fact that an application can have both a server side and a client side. So I've written a little blog post on how to integrate with Auth0. It takes about 10 lines. It's actually using the node library. Because our server is the source of truth, it just pulls a lot of stuff into the server and uses a node library. So it's really quite simple. I've written a blog post, and what I will do is I will link to that at the end of in the end of this presentation. Okta is very similar to Auth. It's a bit more enterprisey, a bit more, it deals with SAML and it deals with Microsoft Active Directory and things like that. It's very similar to Auth and probably has a similar authentication integration pattern. These are really good options if you're not really bothered about the fact that you might have to go off to another provider to log in and then get redirected back to your application. They're a great solution if you don't want to manage your whole user's authentication journey. However, you are of course outsourcing all of your user data, your whole user database, to a third-party provider. So your mileage may vary, it's kind of up to you, but these are there if you need them. So we thought we'd have a quick walkthrough of the application. As you can see, it's very basic. It's a fork of the official Sapper template with a few menu items removed and a login added in place. So if you choose a user, we have 3 user types. So we have regular, owner and admin. The regular user obviously being a customer with the least access. We log in as that user. You can see that we end up with a user's profile. A new profile menu link has appeared because we're now authenticated, so we've wrapped that in a conditional. It shows you the user's name, it shows you the user's email address, and it also shows the user's scopes. Scopes is basically a list of permissions that user has. If we log out and cause the server to delete that cookie, we can then log in as a different type of user. So we've got owner and admin, admin being the highest level of privileges and owner being the sort of middle level of privileges. So the owner has a very similar profile, however they've got a second, well they've got 2 different scopes here. They've got owner and moderator. You can have multiple scopes, so the goal being it's not one permission to one action. What it is a list of things you can do and a list of things you can't do. And the Sapper RBAC plugin will help you with this. And the owner has a third menu item. Again, it's yes, we're authenticated, that conditional pops with these extra menu items, but then also on top of that, we say if they have a certain role, we can show this My Organization menu item. When we click that, we can see their very, very exciting My Organization page. You'll notice when you're logged in, if you click on the home page, you no longer see a login form, you just see you're logged in as an owner or logged in as whoever you're logged in as. That's a conditional as well. Hide the login form if the session is authenticated and show it if not. If I log out now, you can see I've got the login form back. So just for completion, we're logging as an admin as well. Log in there. And again, this has a different menu item. It has admin tools. The My Organization has disappeared. That's not at their level. They don't have organization scope. They have admin and secret. So admin page, super, super interesting. Wow. And that's it. But basically this is a full working SSR example, no flashes of content, nothing like that. So as the code walkthroughs, we have a basic Sapper application here. The only difference you might notice is that we have a Backend Directory. So the Backend Directory contains the API. I normally wouldn't embed the API inside the Sapper application. The reason I've done it is because when I run npm run dev, I'm now running both the backend and the front end at the same time to save myself a bit of time. The Backend API is a simple, happy application, the entry point being server.js. It starts a regular happy server on a regular port. It adds some cause config so that it will always work no matter where you request it from. And it sets up using this auth module here. It sets up the auth strategy. So it registers a plugin, so it's registering the auth plugin. It's then getting the strategy out of the configuration object here, the auth class, and then it's setting that strategy on the API. This is how Happy's plugin architecture works. It's very modular. It then adds in all the routes, which I'm importing from the routes file up here, and then it starts a server so that it starts serving an HTTP endpoint on localhost 2000. And my Sapper application then runs on 3000. So let's take a quick look at the auth configuration. So all it's really doing is pulling the plugin in. It's then configuring the plugin with the strategy. So you can see it's got the verify algorithm, it's got the validate method here. Now, in a real world scenario, I haven't done it for simplicity reasons, but in a real world scenario, what I would do here is verify the JWT signature to ensure that should this cookie have been tampered with, should this JWT have been tampered with, it can be, notified as such and deleted from the user, and the user will be logged out at that point. When we create the JSON Web Token, we grab a bunch of information from our user's database, which is very basic, you'll see in a minute. We set an expiry date, and then we just sign the JWT with that information and our secret seed, which is never given to anyone else, it's just a complete secret. That will mean that we're able to verify this token on the server side. We also have the cookie config here, which is basic cookie config. The important things are the domain. Anyone who wants to see this cookie needs to be on the same domain, in this case localhost. And the other part is HTTP only. Now the reason this is important is because this is the flag that prevents client-side JavaScript from viewing the cookie contents, or viewing even the existence of the cookie. And the path should be set to / because that means anything lower down than the root of the application will receive this cookie. So, in the Sapper application itself, basic Sapper setup, standard, I'm sure you're used to it. You've got source and you've got roots. And of course the index root has got this login form that we used. So here's the login form. Bit of nice HTML there. As you can see, it looks inside the session store, and if it's authenticated, it just prints a message rather than showing the login form. Now this session store, as you remember from the presentation, it contains two objects, authenticated and profile. Now this session store is brought into the application from Sapper app, which is a generated node module that contains various application-specific things such as goto and the stores method. From the stores method, we can deconstruct any of the internal Sapper stores that we want to, such as session, page, and a bunch of other ones. So this is super important because this is how you're getting that session in order to use it in your front end. I've just remembered I haven't shown the roots file in the backend. Let's flip back to the backend for a second. Here's our user's database. I told you it was complex, it's just a big JSON map. And here's our three roots. So we've got the first root here, and this is the create session root. Basically it takes from the payload the information, the email and password sent to it. It looks up that in the JSON. If it exists, it validates that the password matches the super secure password user123, of which every user has. And if that's the case, it then sets, now state in happy means set cookie. So it sets this cookie with a cookie name myJWT. It sets the actual JWT itself, which is created by create JSON Web Token. And it passes a cookie config so that that cookie is set with the correct parameters, HTTP only, the correct domain, the correct path, etc. If the password by any chance doesn't match, it just returns a 401 saying sorry, but there's no dice. The delete method, the delete root again does a similar sort of thing. It deletes the session cookie, so unstate, the opposite of state I guess. Same cookie name, myJWT, same cookie config, that's important because you're unstating the same cookie, and then returns an OK saying you're logged out. And then the final method, the get, which is who am I, this returns the profile information. And you can see what it does here. Because the default authentication strategy is JWT, it can immediately fetch that information from the authentication path to it by the Sapper application, and it will return the credentials. So that's going to give you the full contents of that JWT. So back to the front end. You've got these admin specific pages that don't say anything interesting. You've got organization page and you've got the profile page. And the profile page, now this is fetching information using the preload method. This is the server-side rendering only. Well, it runs in both, but it's initially how the page gets data so that it can be rendered on the server side. So this preload method, the second parameter is that session store we talked about, and it just returns that as the profile variable. It returns the whole contents of that session store's profile object, which is the contents of our JWT. We can then receive that in application and we can use it in the HTML. And that's about it really. We can see conditionals. Our fetch method here, this is probably worth looking at. So this fetch method, it fetches from our API. Again, note it's on localhost, so the cookies are getting sent to it. We're making sure that all the cookies are sent to it by using credentials include. We're doing it in mode call, so we don't get rejected for cross-origin reasons. We're passing the content type application JSON. All this stuff can be smoothed over with the Sapper HTTP client I mentioned earlier. But for now we pass it in because we're using basic browser built-in fetch. And then it stringifies the email and password we've sent in that form and sends it to the API. So that fetch method is sending the login information, and when the response from the server comes back, that contains our cookie. So we're then authenticated. Now, the crux of the operation here, of course, is the server.js. The server.js file is the file that defines the node server which runs the Sapper application. It looks very similar to any other Sapper application with two small differences. One, we've included the cookie parser express plugin. This is so that the cookies on the request are automatically passed by Polka in this instance, but it can be Express too. They're automatically passed and they're then appended to the request as rec.cookies, which we fetch here. Now, the really weird bit about this, you might notice, is the inline middleware they've created. The Sapper RBAC plugin, again, smooths over the bit for you, but the reason this is done, what we're doing is we're creating an inline middleware. We are doing some stuff, and then we're returning the real Sapper middleware, and we're calling it on the way out with the information passed to us by the Polka server. The reason we do this is twofold, actually. The first reason is because we can do all this fun stuff and augmenting the request object. We can't do that in the Sapper middleware. We have to have our own middleware to do that. The reason we don't just add it in the stack and we wrap it instead is because the Sapper middleware is very greedy. So this comes into the second reason we wrap the middleware. So the Sapper middleware, the moment you put it in your stack, it suddenly absorbs all the routes and handles all the routing by itself because of the file system routing, I assume. It's very greedy. So you can't define other routes outside of Sapper, which is obviously fine, but not great if you're trying to do special authentication routes such as callbacks. So what we do here, we wrap it so that we're not dealing with that up front. And in here we can slot a sort of route guarding middleware or something. We can say, given these routes, allow these, disallow these, such as the Sapper RBAC plugin. So again, it's a weird thing, but we wrap it to ensure that Sapper middleware doesn't just sweep up all the routes for us and handle everything, because we really don't want that. So what we're doing in the middleware is we are calling the session method. So the session method allows you to precede that session on the server side. Anything you return here, in this case we're returning the profile from the JWT, we're returning the authenticated flag, which is basically if is there or is there not a profile. If there is, it's authenticated. If not, there is not, and it's not authenticated. What we return here ends up in the Svelte, the Svelte and Sapper session store, which is that reactive store that contains the session information. And that's what we're using when we pull it in the front end, using stores and session stores there. That's it. And that's it. Thank you very much. We'll do a quick demonstration of the application. There's two links here, so you can view this presentation probably a bit slower if you need to. And also there's a link to the MVP application that I've built, which we'll walk through if you want to just play with that or use it as a boilerplate for your own authenticated application perhaps. Thank you very much.